So there's two things that really fluctuate in this problem. We can choose how much of food A and how much of food B we want to purchase. So we can call food A X and food B Y, or we could just call them A and B. That makes more sense. Nothing else really fluctuates. They tell us a whole bunch of information, vitamins, minerals, and calories related to them, but those stay constant. You get 50 units of vitamins from food A. That's not a variable, the 50. Okay, depends on A, but 50 itself does not fluctuate. So let's start trying to make some equations using those variables A and B. They tell us each unit in food A provides 50 units of vitamins, 30 units of minerals, and 10 calories. Each unit of B, 20. Okay, so they tell us how much of each. Let's make an equation based on the amount of vitamins. There's 50 units of vitamins from A, and if we add that to the 20 units of vitamins that we're going to get from B, we don't know how much B we're going to get, but we know that we get 20 units of vitamins from each. This needs to be at least 2,400 according to the instructions we were given at the top. At least 2,400. So this is our vitamins equation. We need to make an equation based on the number of minerals, and it says we get 30 minerals from food A, and then 20 minerals from food B, and that needs to be greater than or equal to 1,800. And then same thing for an equation for calories. Food A gives us 10 calories. And then food B gives us 40 calories. This needs to be greater than or equal to 1,200. They need at least 1,200 calories. Okay, so we're supposed to compare all the infinite possible solutions to this problem to a cost function. And the cost function depends on A and B, right? It depends on how many items of A, how many, I don't know what this is, units, how many units of food A that we buy. And it depends on how many units of unit B that we buy. The cost function is $2 for every A unit plus $1 for every B unit. So this is a linear programming problem. You want to graph both of these, and we only care about positive because you can't have negative units of food. Okay, so you want to graph them, and then once you graph them, find the places of intersection, and then you can use those places to find out which one is going to be the max and the min, because the maximum or minimum of a linear programming problem is going to be at those intersection points that we're going to find. So let's do this one in red. Cover up or solving by finding the intercepts is going to be the easiest way. We're going to plug in 0 in for B to solve the A intercept, or we could call this X and Y if you have trouble graphing A and B. Right, this is like my A axis, which would be the X axis, and this is like my B axis. But if I plug in 0 in for B, then I've got this equation 50A equals 2,400. So I need to divide 50 from both sides. So that's 48. I'm going to put 48 right here. It doesn't have to be perfect. We're just making a sketch. And then I'll do the same thing. I'll plug in 0 in for A this time. It's 48. I'm going to plug in 0 in for A and then solve for B. So 20B equals 2,400. So 120 on the y-axis. That's our y-intercept. So that's the first line that we need to draw. We'll do the same thing for the next one. I plug in 0 in for B and solve for A. That's 60. So 60 on my A-axis, which I said was going to be my x-axis. So just plug in a number slightly bigger than 60. Then do the same thing. Plug in 0 in for A and solve for B. So 1,800 divided by, oops, it's too many. That's going to be 90 when you solve for B, right? So 90 is somewhere down here. Again, does not have to be perfect because we just need to visualize how these lines cross with one another. And then the last one I'll do in a green color. Plug in 0 in for B and solve for A, so you get 120 on the A-axis. And then plug in 0 in for A, solve for B. What is that, 30? So there's a line that connects those. Okay, so we got to graph the feasibility region. What that means is we got to shade where the possible solutions are. So they all here. I guess the easiest way is to do it like I did in another video. Plug in a test point to check. So I'm just looking at the red line right now. If I plug in 0, 0, 0 goes in for A, 0 goes in for B, so we have 0 is greater than or equal to 2,400. That's not true, right? It means any other point I pick on this side of the red line is going to be false. That means my red solution is going to be where all my red dots are. Okay, that's the solution area for red. And I'm not going to consider negative values for A or B. For the blue line, same thing. Plug in 0, 0. That is 0 is greater than or equal to 1,800. That's not true. So this side is false of the blue line. So this side is true on the blue line. I'm focusing on the blue line with my mind, and I'm putting dots on this side of the blue line, the top right side. Then do the same thing for green. If you plug in 0, 0, it's false again. So this is the, oops, I didn't mean to change those colors. There we go. So this is the solution area for green. Now we're looking for where all three colors match, and that's our feasibility region. So for this problem where we have green, blue, and red, oh, there we go. Where we have green, blue, and red is right here. It stops on this red line, then it follows this blue line, and then it follows this green line. That's the only place where all three of those colors are present. So this is our feasibility region. So when we solve this problem, this linear programming problem, we're particularly interested in this point, and this point, this point, and this point. Okay, those are the four possible areas that could minimize this cost function. So you want to know those coordinates. The ones on the x and y axis are easy. This is at 0 on the x, 120 on the y. This is at 120 on the x, 0 for the y. But these points, if you need to calculate what those are, you want to find out where my red line crosses with my blue line. So where this line crosses with this line. So you want to solve this, this system of equations. Because when you solve a system of equations, you find out where two things cross with one another. And the easiest way to solve this one, the system of equations, is to multiply the entire bottom equation by -1, keeps it the same equation, then add the top equation to the bottom equation. So when I solve, I get A is 30. So that's the x-coordinate, the a-coordinate in other words. To find out the b-coordinate, I could plug 30 into either one of the two equations and it should give me the same thing. So if I plug in 30 in here, that's 900 plus 20b equals 1,800. So subtract that 900 from both sides. Divide both sides by 20. So 900 divided by 20 makes 45. So it's 30 on the x, 45 on the y right there. Okay, I also need to find this intersection point. So that's where the green line crosses with the blue line. So the green line and the blue line, we'll set those aside and solve them as a system of equations. It'd be easier if I type. Okay, so the way I'd solve this system of equations, I'd multiply the entire bottom by -3. So that makes -30. And then that's -120. And then multiply this by -3. So that's -33,600. Just making it look a little neater. Okay, and then we can add the top equation to the bottom equation. So it gives us -100b equals -1,800 when you add these together. So in other words, b is going to be 18. So that's the b coordinate, the y coordinate in other words. To find the x coordinate, you can plug in 18 into either one of these two equations. So I'll plug it into the top equation. So 30a plus 20 times 18 equals 1,800. So 20 times 18 is 360. Subtract 360 from both sides. 1,440. Then divide 30 from both sides. So we get 48. So we found out 48 is the x coordinate, 18 is the y coordinate. So 48, 18. Okay, so those are the 4 points. All you have to do now, I know it's a big problem, but one last step. We're trying to minimize the cost. We're plugging in 0 in for A, 120 in for B to find out its cost. And this one, the cost is 120 for this point when you plug those two numbers in. Plug in 30 in for A, 45 in for B. So that's 60 plus 45. So this one is the winner right now. It's 105. Plug in 48 in for A. Plug in 18 in for B. This one's 114. And the last one, plug in 120 in for A. That's not going to be it. That's 240. Okay. So the one that minimized the cost was this one. So you should buy 30 units of A, 45 units of B. Sorry, so the problem said, what is the minimum cost? We found out 105 is the smallest cost.